Hello guys, you are welcome to the GMAETS 41's YouTube channel. As some of our channel members prepare for their chemistry practical examination, I thought it wise to teach you this aspect of qualitative analysis, which focuses on organic chemistry. You are going to learn how to analyze and confirm the presence of hydrocarbons, alkane, alkene, and alkyne. It is important, as I usually state in my previous video, that as a student prepare for practical aspects, it's important for the student to have certain basic theoretical knowledge of what he or she is entering the laboratory for. So that whether you are exposed to real life practical or you are exposed to alternative to practical, you'll be guided by your background knowledge in that practical aspect to be able to deal with whatever question that you are exposed to. So I'll quickly make a review of what you should know when testing for hydrocarbons. Okay? Alkynes, alkenes, alkanes. Usually, we make use of potassium permanganate, that is potassium tetraoxomanganate 7, KMNO4. We also make use of ammoniacal silver trioxonitrate 5, ammoniacal silver nitrate, mixed with aqueous ammonia. In place of silver trioxonitrate 5 mixed with aqueous ammonia, that is ammoniacal silver nitrate, if we don't want to use that, we may choose to use ammoniacal copper 1 chloride. That is copper 1 chloride mixed with aqueous ammonia. No, our aqueous ammonia, we also call it ammonium hydroxide. So these are the reagents that we use to test and confirm the presence of hydrocarbons generally. Having said this, how does an alkane behave when you expose it to potassium permanganate or ammoniacal silver nitrate? Now I want to know that this hydrocarbon alkane does not show any positive reaction with these guys. Okay, it doesn't show a visible reaction with this reagent potassium permanganate or ammoniacal silver nitrate. Which means if you expose the given hydrocarbons to these particular reagents, and there is no change, okay, no precipitate formed, no color change, then you know that the hydrocarbon is an alkane. What about alkene? When an alkane is exposed to potassium tetraoxomanganate 7, this purple color solution will become colorless. Alkyne also does that. So there is this, challenges when it comes to alkene and alkyne, using potassium permanganate as our test reagent. Since both of them, they behave alike when they are exposed to potassium permanganate. So for this reason, we introduce the next reagent, that is ammoniacal silver nitrate. Or like I said, we can use copper 1 chloride in ammonia, that is ammoniacal copper 1 chloride. Now this reagent is used to distinguish between these two unsaturated compounds, alkenes and alkynes. Alkenes will not react with these guys. Okay? When you expose this solution, ammoniacal silver nitrate or ammoniacal copper 1 chloride, to an alkane would have no effect on them. So no visible reaction. However, if you expose these solutions to an alkyne, terminal alkynes to be specific, that is alkynes that have their triple bond on carbon number 1, the first carbon, there is going to be a color change. Are you getting me right? This reagent, ammoniacal silver nitrate, is going to produce a whitish precipitate. That whitish yellow, okay? Just simply whitish precipitate. And then if we make use of ammoniacal copper 1 chloride, we're going to see this reddish brown precipitate color change. Okay, and this helps us to know that the hydrocarbon present is an alkyne. So with this background knowledge, you can actually be able to identify and confirm the particular hydrocarbon present if you are exposed to them in your laboratory work. So friends, just follow along. On the screen, the instruction we are going to follow to carry out this descriptive analysis in a tabular form is going to display. Follow through as the instruction displays, read through as well too, and then as I make the analysis in a tabular form, make sure you follow through meticulously so as to understand how the analysis is being done to confirm the presence of an alkyne, alkene, and alkane. Please watch. 3 liquids labeled A, B, and C suspected to be pentyne, pentene, and propane were kept on a laboratory shelf Lucy. In a tabular form, describe how you will identify and confirm the content of the liquids using potassium permanganate and ammoniacal silver nitrate. So what we're going to do, as the instruction requires, is to describe in a tabular form how we would identify and confirm the content of these 3 liquids. So we have A, B, and C. We don't know what these guys are. They are liquids, but they are suspected to contain pentyne as an alkyne, pentene as an alkene, and propane as an alkane. So we're going to see how this will be done, assuming you are seated in an examination. Remember, we are to describe this in a tabular form. Alright, so we get to business. As usual, our 3 columns, test, observation, and inference column. Now the first thing I want us to do is to describe how we would identify A. So we are carrying out our test on A. We are using potassium permanganate and ammoniacal silver nitrate as the instruction requires. So number 1, I am going to expose A to potassium tetraoxomanganate 7. So if I expose this potassium permanganate to A, it's much like adding potassium permanganate to liquid A in a test tube. Under the test column, we are simply going to have A plus KMnO4. If you wish to write it in full, potassium permanganate, the choice is yours. Now let's assume that the purple color of potassium permanganate becomes colorless. So under the observation, I am going to write the purple color of potassium permanganate becomes colorless. What will be my inference in this case? Remember your theoretical background of how these hydrocarbons behave when they are exposed to potassium permanganate. With the fact that the purple color of potassium permanganate becomes colorless, this simply means that alkane is absent. Alkane in this case is propane. So propane is what? Absent. Therefore, we are left with our propene and pentyne. We are left with propene and pentyne. And these 2 guys are unsaturated compounds. And so I'm going to write in the inference, A is unsaturated compound, pentene or pentyne suspected. Remember, we've eliminated propane, our alkane, because alkane will not affect the purple color of potassium permanganate. But in this case, I am assuming that the purple color of potassium permanganate became colorless. So that eliminates our propane. It means that liquid A cannot be an alkane. So we are left with the 2 unsaturated guys, like I said, which are pentene and pentyne, suspected. We use the word suspected because there are 2 guys here that are still challenging us. Pentene and alkene and pentyne and alkyne. The next step will help us to distinguish between whether liquid A is an alkyne, pentyne, or whether it is an alkene pentene. So that takes us to number 2 analysis. I am going to expose A to ammoniacal silver nitrate. In doing this, if it is live practical, then I will be expected to add ammoniacal silver nitrate into the test tube containing liquid A. And so under the test column, number 2, I have A plus ammoniacal silver nitrate. Now let us assume that a white precipitate forms when I add ammoniacal silver nitrate to liquid A. If a white precipitate forms, it simply means that A is an alkyne, which in this case, pentyne. And it simply means that out of the 3 liquids, A, which showed this observation with this reagent, is simply pentyne, an alkyne. And so under the inference, we simply have that A is alkyne, which of course from the instruction, the alkyne there is pentyne. And I could simply say confirmed. This is interesting, isn't it? So we've been able to identify what liquid A is. It is pentyne according to our instruction. But remember, we had to carry out tests to confirm that liquid A is pentyne. And please remember, I decided to start with A with this assumed observation. I could have decided to start with B and then have this observation assumed. In that case, it means that what I am going to confirm B to be is the pentyne, that is alkyne. But it doesn't matter. We don't know what these guys are. So if I decide to say, okay, let me assume A to be an alkyne, going through this test method and then observing this as written under the observation column would give us the inference made already. All right, let us move on to liquid B. Now in this case, I decide to expose liquid B to ammoniacal silver nitrate. So imagine that I add my reagent ammoniacal silver nitrate into the test tube containing liquid B, which I don't know what it is. And then imagine that there is no visible reaction. That is, nothing happened to the ammoniacal silver nitrate solution. The mixture of liquid B and ammoniacal silver nitrate in the test tube, nothing happens. Okay? If this is the case, it simply means that alkyne, which according to our instruction, pentyne has been used to be the representative member, is absent. The reason is because, alkynes, terminal alkynes, as I stated already from our theoretical background knowledge, okay, alkynes would affect ammoniacal silver nitrate solution given a white precipitate. So if it happens that, okay, I am assuming that on adding ammoniacal silver nitrate to liquid B, there was no white precipitate formed, no visible reaction. It means that I have eliminated possibility of B, liquid B, being an alkyne, pentyne in this case. And that is why under the inference, I had to write, and that is why under the inference, I would have to write alkyne, which is pentyne, absent. Now, if possibility of B being pentyne has been eliminated, it means that we will be suspecting liquid B to either be propane or pentene, that is an alkane or alkene, because these two guys do not react, they do not show visible reaction with ammoniacal silver nitrate. And hence, I would write alkane, propane, and alkene, pentene, suspected. Remember, you use the term suspected when you still have this challenge, okay, that there are 2 or more things likely present. All right, this takes us to number 4. Now that I am suspecting B to either be a propane or pentane, I would have to distinguish between them to be sure of what B really is out of these two. And hence, I decide to expose liquid B to potassium permanganate. So number 4 test, under the test column, I have B plus KMnO4, that is potassium permanganate. Now I'm going to assume, remember this is alternative to practical. I am asked to describe how I can confirm what the hydrocarbon that is actually present. So I am not assuming that when I added, potassium permanganate to the liquid B contained in a test tube, that the purple color of potassium permanganate becomes colorless. Okay? So if the purple color of potassium permanganate becomes colorless, it means that liquid B, which was suspected to be an alkane propane or to be an alkene pentene initially from test number 3, it means that that liquid B actually is an alkene. Pentene in this case according to our instruction. So why are we going for pentene, which is an alkene? Because I am assuming now that, there is a color change, The purple color of potassium permanganate becomes colorless. So if that is the case, it means that B in this case would be an alkene, because alkene would usually decolorize potassium permanganate. Remember that alkyne also decolorizes potassium permanganate. But B cannot be an alkyne in this case, since test number 3 with ammoniacal silver nitrate has eliminated the possibility of liquid B being an alkyne, that is pentane. We have eliminated that possibility. So we are working only with pentene as an alkene and propane as an alkane, which according to test number 4, we found out that the purple color of potassium permanganate became colorless. Out of alkane and alkene, what will decolorize potassium permanganate is alkene. Therefore, we infer that liquid B is an alkene, which is pentene confirmed. This takes us finally to liquid C. We want to find out what liquid C is. We've been able to confirm our alkyne, that is liquid A. We've been able to confirm our alkene, that is liquid B. One could just conclude saying that liquid C is alkane, that is propane confirmed. But remember, you are asked to describe how you would confirm this guy. So you would not just make a conclusion like that. You need to show under the test, observation, and inference what would happen if C is actually an alkane. And so we move on under the test column. Procedure number 5. To liquid C, I am going to add ammoniacal silver nitrate to liquid C, supposedly in a test tube. Do not forget, this is alternative to practical. So we are just assuming that if we were to be carrying out this life, this is what we expect to happen. And if this happens, then this would be our conclusion. Liquid C plus ammoniacal silver nitrate. Now, assuming that there is no visible reaction. So I observed in the test tube that no visible reaction. Alright, there is nothing that happened when I added the ammoniacal silver nitrate to liquid C. The inference would be that alkyne, which according to our instruction is pentane, is absent. Alkyne, which is pentane, is what? Absent. The reason being simple. If an alkyne is present, terminal alkyne particularly, then there would be a reaction. That ammoniacal silver nitrate would produce white precipitate. Alright? But we are assuming that our observation, there is no visible reaction. It therefore means that alkyne has been eliminated. Pentyne is not liquid C. Hence, we are left with alkane, which is propane, and possibility of liquid C being an alkene, which is pentane. So under the inference, we have alkane, which is propane, and alkene, which is pentane, suspected. Now there is this issue that we are suspecting liquid C to either be propane or to be what? Pentane. We have to go further to distinguish between these two hydrocarbons and be sure which one is liquid C actually. So I am going to expose liquid C to potassium permanganate, and under the test column I have procedure number 6. Now suppose that I add potassium permanganate to the test tube containing liquid C, and again there is no visible reaction. It simply means that liquid C is an alkane, which in this case is propane. So I would write that C is alkane, propane confirmed. The reason being that, from test number 5, we already eliminated alkyne. Pentyne has been eliminated. We are now struggling with whether liquid C is propane, an alkane, or pentane, an alkene. Following step 6, okay, procedure number 6 under the test column. If C is an alkene, then the purple color of potassium permanganate will be discharged, will become colorless. But here we are assuming under the observation that on adding potassium permanganate to liquid C, there is no visible reaction. It simply means that C is not an alkene. Rather, C is an alkane, which is propane. And so propane has been confirmed to be liquid C. So dear friends, this is how we can describe, the confirmation of hydrocarbons in the laboratory, which is an alkane, propane according to our instruction, which is an alkene, pentene according to our instruction, and which is an alkyne, pentyne according to our instruction. Alright guys, I hope you enjoyed this tutorial. Please hit the like button, give the GMAETS 41 thumbs up. If you are yet to subscribe to this wonderful channel, hit the subscription icon. Turn on the notification bell so that once I upload any new content, you will be personally notified. Remember, you can also become a channel member so as to get further beneficial learning. To do that, tap the join button below this video lesson, then choose the package that is convenient for you. Once you do that, you become a channel member and you can gain exclusive benefits specifically for our channel members. Please friends, do share this video lesson also to your friends and other scholars so that they can benefit from it as they prepare for their examination. I hope to see you in our next tutorials. But until then, the GMAETS 41 wishes you the best in your examination. And for all those that will be taking this tutorial in preparation for their exam, any other time, I wish you all the best. Take your studies seriously. And always check back, as GMAETS 41 has wonderful concepts for you in your mathematics and science subjects and courses. I will see you in my next video lesson.